Hi everyone, welcome once again to another machine learning tutorial session. In today's video, I'm going to show you how you can build a neural network model for cancer prediction. We are going to use Python for this exercise. The notebook for this tutorial is available. You can go and then download it. If you want to run the notebook locally on your PC, you need to make sure you have these libraries installed: NumPy, Matplotlib, Pandas, TensorFlow, Keras, and then scikit-learn. You can also run this particular notebook using your browser, so I'll show you how to do that. This particular approach is useful if you don't have Python installed on your PC. The notebook is available on my machine learning GitHub repo, so take note. I will leave the link to this repo in the description box. And so when you visit the link, search for notebooks/projects. In this particular directory, search for a notebook called Neural Networks for Cancer Prediction, episode 1. So click it. And then after clicking, you'll have this page coming up. So search for Open Colab. Okay, Open in Colab, this button here. So once you see it, just click it. And then Google Colab will open the notebook for you. You should also make sure that you have signed into your Google account. Okay. Signing into your Google account will help you to run the notebook using the Google Colab platform. Perfect. So now let's proceed. I will switch to my notebook here. Okay. The first thing we have to do is to import our libraries. So this cell will help us do that. So I have libraries for data handling, data visualization, preprocessing, and then classification. So I'll run this cell to get everything I need. Now, if you are running the notebook locally on your PC, you may have this error message coming up. Okay, so this error message here is coming up because I don't have a particular library installed, okay, or available on my PC. This error can be ignored because I don't have the GPU version of TensorFlow. And I also don't have this particular library, so that is why I'm having this. But you can ignore it since we are not using the GPU for this exercise anyway, so take note of that. Now let's proceed. I'll now read my data. Okay, so this code here will help me do that. The data I'm using is available on my machine learning GitHub repo. You can check it out. I will leave the link in the description box for you to use. So I will supply Pandas with the URL to that particular file, and then Pandas will read it. So that's what I am doing here. So I'll run the cell. Perfect. So now I am going to explore and then do some cleaning. Whenever you are doing machine learning work, it's important to always do data exploration. Okay, data exploration will help you to understand the data and will also help you to select the appropriate methods for the downstream analysis. So I'll do a bit of exploration here. The first thing I have to do is to get the dimension or the data size. So I'll use this command to help me get it. So I have dataframe.shape. So I have 801 samples, and then the columns here are 8001. So the columns here, 8000 of the columns are features, and then the last column is the outcome or the class or the cancer types. Okay, so take note of that. I'll print some of the columns. So here I am printing just the first 3 columns. Perfect. So these are the column names. So these are the features. Let me also get the last column, which will be done using this cell. Okay, so the last column here is the cancer type. So here I can go further to get some of the cancer types. Let me just show it here. So I can just say data frame cancer type .head. Okay, so I have some of the cancer types here. So these are the types. Notice that here these are categorical values. Okay, so I'm only giving a cancer type. So later on I'll have to encode. We'll do that later on. So this is how the classes have been given to us. We also need to check for missing values. It's always important to do that because missing values can have a negative impact on your model. So you have to check. So this cell here has codes that will do that for us. So I'll run this. Perfect. So here I don't have any missing values. So it's good news for me. I'll check the count of the classes. I want to know how many cancer types are available. Okay, for each cancer type, how many instances are there, or how many samples have been labeled with that cancer type. So I'll run the cell to get it. Perfect. So I have the count here. So I have 5 cancer types: BRCA, KIRC, LUAD, PRAD, and then COAD. So this, I think this breast cancer, this is kidney, this is lung, prostate, and then this is colon. I'll leave the descriptions in the description box, so take note of that. So the full names will be given in the description box. Okay, so there are 5 cancer types or 5 classes, and so here we are dealing with a multi-class problem because the number of classes here are more than 2, so it's a multi-class problem. So take note of that. We are going to do some pre-processing here as well. So first, I'll separate the features from the class. So I'll do that here. Perfect. And then I'm going to encode the labels. Encoding is important. Okay, I made mention that the classes have been given in this form, but with machine learning tasks, it's always important to represent these classes with numbers. Okay, so numbers, integers for that matter. So that is what the encoding here is for. So we are going to encode our labels, okay, between 0 and then n classes -1. Okay, so we are using label encoder to do this. So the code here will do that, and I also want to get the number of classes. Okay, that information is important. We will use it when we are building the neural network. So let me run this cell to get everything going. The next thing we will do is to normalize the data. Normalization is done so that we can get the values of all the features within the same range. This helps to improve the model performance and also helps the model to avoid bias. So I will scale the data between 0 and 1 using the min-max scaler. So I'll run this code. Okay, that is done. Now we are going to split the data. So here we will split the data into 3. We will split the data into training, validation, and test sets. The training set is used for training the model. The validation set is used for evaluating the model during training, and the test set is used to test the model after training and tuning has been done. So this code here will do the splitting. So notice first I split the data into 2, training and test set, and then I come back again here, and then I split that training data from this into 2, into another training and then validation. So it's important to always do that. Okay. So I'll run this code to do the splitting. So now I have training, validation, and then test subsets. You can do some exploration here as well. You can just check them out. Perfect. Let me just do a quick one here. So xtrain.shape. So we have 5.2. I can also just do xtrain. Let me just check the data type first. So I see type xtrain. Okay, so it's a numpy array, so I can say xtrain 0 and I'll say 0 to 10. So I just want the first 10 samples for the first 10 columns. Perfect. So I have the values here. So these are things you can always do. Okay, so just make sure you do those stuffs. Okay. Now let's proceed. So it's now time to build a neural network model. Okay, so to build it, you first need to define it here. and after defining, you add your layers. Now with a neural network, we have inputs, hidden, and then output layers. If you check the codes here, there is nothing like an input layer. And this is because Keras allows us to use just hidden and then output layers, okay, for classification. So that is why I don't have any input layer here. And because I don't have an input layer, I will still need to make sure that the first hidden layer here has information about the data. So the information here is the dimension, okay, the number of features. So that one is here. That is what I have here. And I also define the number of neurons, which are here. So here, there is no standard number, okay. Some of these architectures, the optimum architecture or the best architecture is obtained by experimentation. So you always need to experiment and then get the best architecture. So these ones I have preset them because I found this configuration to give me a good result. So that is why I'm using that number here. The activation function is ReLU, that's a rectified linear unit. There are a number of activation functions available, but ReLU is one of the common ones, and it also works well in general. Okay, it performs well in general, so that is why I am using that. I add another hidden layer. Okay, so here it's 20. The number of neurons are 20. I also use ReLU here. Now I add my output layer. So the output layer here, you need to also define the number of classes. Okay, because we are dealing with a multi-class problem, you have to put the exact number of classes here. So in this case, it's 5. So that is what I define here. When you come here, I have n classes here. Let me show you. So n classes is 5. So that is what I am putting here. And then I'm using activation function softmax. That is what I am using here because I'm dealing with a multi-class problem. Okay, now I'll define an optimizer here. Okay, and I also define a learning rate. So I'm using this tutorial to also let you know some of the parameters that you need to add, or you may need to also tune or fine-tune when building a neural architecture. So one of them is the learning rates. So I have my optimizer and then a learning rate. So I now compile the model here using a loss function, which is sparse categorical cross entropy. And then I also specify my optimizer here. So again, the loss function here, there are a number of them, and then it will depend on whether you are dealing with a binary classification or a multi-class classification problem. So you need to also look at that. And also, if you are dealing with a multi-class problem, the kind of encoding you use to also determine the loss function that you need to use. So again, you need to read about the loss functions available and then look at the one which is appropriate for your work or for your data. So take note of that. The metrics, I'll use sparse categorical accuracy. Okay, so these things you always need to read and then make sure you get the appropriate ones, because what you input will determine whether the model you have can be trusted or not. So you make sure you do reading, make sure you experiment, make sure you consult, and then get the best parameters to use. Okay, so I'll run this. Perfect. Again, if you are running the notebook on your PC, you may have this error coming up, but you can ignore because we are not using the GPU version of TensorFlow. Okay, so let's proceed. Now it's time to fit the model to the training data. So that one is done here. Okay, so we have our training data. We also have our validation data, which is used to evaluate the model during the training. Okay, so it's used for evaluation and then tuning. Perfect. I also define a batch size and then the epochs. Okay, the epochs here. So the epochs tells us how many times the data is fed through this particular network. So take note of that. So I will run this particular cell to fit the model to the trained data. And I also specify a history here. So the history here keeps records of what is going so that later on we can visualize. Okay, that is why I have this here. So I'll run this code. Okay, so let's check. It seems Keras and TensorFlow are still running. Okay, so it seems now they are done. I had 200 epochs, so I'll check. Okay, so that is done, I suppose. Okay, so you can also see what is happening. Check the sparse categorical accuracy which we set and the validation loss. So you can see that for the epochs, things change. You see that the accuracy is changing, loss is also changing. Okay, we also have validation also here. Okay, so this here will let you see what is happening, and that is why we also set the verbose to be 1. Let's check here before I proceed. If you check, I have verbose equals 1. So verbose equals 1 lets TensorFlow and then Keras print what is happening to the screen for you. You can set it to 0. If you do that, nothing will be printed. So take note of that. You can also set it to 2. Yeah, I think 2 is also there. So you can use 1 or 2 if you want some of the outputs to be displayed for you. Now let's scroll down. Okay, perfect. So now we are done with training. So it's time to do some predictions. So here we use the test sets, and that is what I have here. So the predictions here, we use this cell to run the codes to get the predictions. So I'll do that here. And after prediction, I also evaluate the model using this particular method here. And I said verbose equals 0 because I don't want any output to be displayed. You can also change it. So I'll just predict here. Perfect. So predictions has been done. Now let's check the accuracy. So accuracy is 1.0, which is perfect. Okay, so because here the accuracy is in a range of 0 to 1, 1 is a perfect model. That is what I have here. Okay, you can even check from here. Here we had 0.9922 during the training phase. So that means the model is performing very well. Now let's look at the predictions. If Keras and then TensorFlow do a prediction, okay, the predictions given, because we specified softmax, okay, the predictions we have are probabilities. Let's check one of them. This is what you have. So these are probabilities. So what you do is that you look for the one with the highest probability, and that is what will be the prediction. And so if you check, let's just say this is the one with the highest probability. You check the index, so we have 0, 1, 2. Okay, so this means that the prediction was made for that particular class. Okay, let's just do something here. So if let's say this is prediction 0, and I want to get the class itself, I'll say np.argmax, and then I'll specify the predictions 0 here. So that gives me 2. That means that index 2 is the one with the highest value. Okay, that's the probability. So that is what you have to go for. So that means the prediction was what? 2. Okay, so take note of that. So I think I also defined the classes somewhere here. I will check now. During the encoding, yeah, so classes. So let's check the classes here. Okay, so these are the classes 0, 1, 2. Okay, Let's also check the labels. Let's check how I defined it. Okay, so I have labels. Yeah, so let me check the labels here. So labels will let us know the exact class. Here we are still using numbers. Okay, so I have this. So 0, 1, 2. So that means 2 here is for what? KIRC. That means that particular entry. Okay, that prediction, that sample was predicted as 2. That is KIRC. So take note of that. We can also check the entries. Okay, the prediction for the first 20 samples. So I have something here. So here I can just do it like this. I have everything I need here. So I'll just run this code. Okay, so let me just run. Okay, so this is what I have. Okay, so you can see that the predictions are all correct. Okay, the same prediction, the predictions made were the same as the actual outcomes, which is here. So you can use this to also do some cross checks. Okay, so these are things you always have to do whenever you are performing machine learning tasks. Perfect. So now we have a prediction here. We have the predictions. So what we are going to do now is to summarize everything, okay, and then visualize it. So that is what this cell here and this cell here will do for us. So we are first going to visualize the training, and then we're also going to visualize the validation. Okay, I made mention that the validation set is used for evaluating the model and also for tuning the model during the training phase. And so we need to visualize what is happening. So I'll use this to first get the training. So let's do it here. Perfect. So this is the model performance. So we have training and then validation. Okay, this is for the accuracy that we set here. So the color scheme here will help you to differentiate, okay, between these plots. So one is for training, the blue one is for training, and then I think the dark yellow or something like that. Yeah, let me just use the word yellow or orange. Yeah, orange. So we have blue for training and orange for validation. So you can see that the accuracy, train, and then validation, they were all improving, and then now they remained constant. Okay, and they are all around the same value. Okay, so this is important because this plot here will help you to know whether the model is overfitting or not. Overfitting is something that happens. Okay, it's something that you always have to check for when building a neural network model. And so because the values are all similar here, we see that the model is doing very well and there's no overfitting, and that is good news for us. Let's also check the loss. Let's run this to check the loss. Perfect. So here we see that the loss also it reduces and then it becomes constant. Okay, so this is also good for us because they are all around the same value. The values are similar. That is why we have the lines just closer to each other. So this is also good. This also lets us know that there is no overfitting, and that is what we want. Perfect. So after training, you want to do this to visualize, and then this will let you know at a glance how well your model is performing. Okay. There are other metrics you can use to evaluate the model, but these are things we'll look at in later tutorial. But for now, I think we'll end here. So this tutorial here has helped you to know how to build a neural network model for cancer classification and also for multi-class classification tasks. So that's it. So that'll be all for this tutorial. Thanks for watching, and then see you in the next session. Goodbye.